All right, guys. Wanted to talk to you about some of this homework stuff. Just give you a heads up on it. Check this out. Here's my take on some of the homework stuff. Okay. Question number one. Here's my version of it. You'll have probably different numbers or whatever, but if 7, 25, and 24 are the side lengths of a triangle, do they form a right triangle? That's what they want to know. They're tapping into what we call the converse of the Pythagorean theorem here. You guys might remember Pythagorean theorem says something like, if I have a triangle with a right angle in it, if this is a perfect 90-degree or whatever, then we'll know that if I call this side A and this side B, and then the slanty side that's across from from the right angle, the hypotenuse side, we'll call that C, say. Then you might remember that A squared plus B squared ends up equaling C squared. That's not obvious, but it does work, Not by any means obvious that works the way it does. There's ways to prove this, tons of ways to prove it, but it's not obvious. Anyway, this is a pretty popular result. I'll feel you guys out and see how comfortable you are with that when we get together. But if you're okay with this, then the converse of that is saying, well, if I have three sides that have this relationship, A, B, and C, such that when I square them all, the little ones add up to the square of the biggest one. If A squared plus B squared does equal C squared, then I can conclude that this must have a right angle in it, Or else if I have A squared and B squared, and I add them up and they do not equal C squared, then it means I have a triangle that has either a funny big angle or maybe they're all just small angles, but this is not a right angle in there either way. If it's bigger than C squared, if A squared plus B squared is bigger than C squared, it tends to be that we have, let's see here, that would probably be this case if I'm thinking about it right, because C squared is smaller than A squared and B squared, whereas if C squared is the bigger one, if we had something like this going on, then C squared is the bigger one. Then we'll probably have C being so big that it stretches our angle out bigger, and it's bigger than a 90. Either way, this, here, we'll just erase all that stuff. This question tends to be easy to approach if we have that perspective. And so all we'd have to do on something like this is say, well, let's see here. Where'd my pencil thing go? The mouse, draw, there it is. Well, let's just see here. 7, 25, 24. 25 is the big dog. Pencil, draw, there we go. Okay, that's the big dog. So that would have to be side C, I guess, as they call it. So then we would just say something like this: 7 squared plus 24 squared. Does that question mark, my dog is barking, does that question mark, keeping on barking. We're just going to ignore the dog if you can hear that in the background. Maybe not, Anyway, does that equal 25 squared? That's what we want to know. And you just run the numbers and see yes or no, does it? And if the answer is yes, then you say, yes, this is a right triangle, and then you just go from there, 49, this is 576, this would be 625 if I square them all. And then I think this does actually add up to 625. So, check those numbers if you want, but I think that adds up to 625. So I'm like, question mark, does this end up adding up to what I want it to? And indeed it does. So then at this point, I'll say, yeah, A squared, B squared does make C squared. So this is a right triangle, That's how I'd handle the first one. After that, we get into more standard Pythagorean theorem stuff. Check this out on number 2 and 3 and beyond for a while. We get into Pythagorean theorem stuff where they're just asking us to run some numbers, find the length of the hypotenuse of the triangle pictured below. We're going to find the hypotenuse here. And, if we take the foundation that we had from last time, then we'll say, well, here's A and B. They seem to make the right angle up. Then this must be the C side, that's across from the right angle, the slanty one. So we'll say 5 squared plus 10 squared equals something over here squared. You could put X or C or whatever you want to call it. A lot of people like C, so we'll do that. Equals C squared, and then just run the numbers from there. If you have an algebra background, then this will be comfortable. This is 25, this is 100. Then we'll say C squared equals 125. And then to undo the squared part, that means C must be whatever the square root of 125 is. Now 125 doesn't square root very well. So what you can do is on your, here, I'll stop the annotation here. In your answer box, what you can do is put just square root of 125, Notice that they didn't ask us to round off the answer to a particular decimal place or anything. So the more accurate, the better if they don't say that. And so I'm betting that's how they want the answer in this case. Let me see if I'm right about that. Yeah, they liked it when I wrote it that way. And so just put square root of whatever you get, just the kind of thing they're looking for there. Anyway, that's all on that one. You get that annotation up here. Let's clear those drawings and then on to the next. Okay. Number 3 and 4 and 5 and all this stuff for a little while. 3, 4, 5, and 6. It looks like, or at least 3, 4, 5. They're the same kinds of things. Sometimes you're not looking for the hypotenuse, though. You notice is the hypotenuse side, the C side is given, and you're looking for one of the other sides. So we'll run through one like that. And then these other ones are all about applications. They're saying what's the altitude of the plane, but you can say that they're asking for the straight up and down distance is what they mean by altitude. And then same thing here, we have a ladder thing. It's got 1 foot and 8 foot, and they want to know how far is the hypotenuse, the length of the ladder until it hits the roof line. You know, it's all ABC stuff. So let's talk about that real quick. If we had one that's twisted around here, say, then we know how that would go, is we would say, well, okay, this is not necessarily the C side this time. This is like side A or B or whatever you want to call it. You could call it A or B. I'm just going to call it X. But what we know is since it's not the hypotenuse side that has a, you know, that's across in the right angle, then that means the 18, that's the one that's the C side, you know? So we'll say X squared plus 13 squared equals 18 squared, and then we'll solve it from there, you know? See if I can remember these. I think 13 squared is 169, and I think this is 324. And then you minus it and square root it. And what you notice about this one, though, is I think that they started asking for, yeah, you'll notice here it says round off to the hundredths if necessary. So they're getting you to start rounding at some point, too. It's more accurate the other way, but it makes more sense in your mind if you go and get a rounded version of the answer. Let's see here. I'll get my calculator out. 324 minus 169 is 155, assuming that I'm right about the 324. Anyway, so then equals 155. And then we'll square root that out. And so then we have X equals whatever the square root of 155 is. Let me square root that real quick. I'm doing this on a phone calculator, so you can't really see what I'm doing. Anyway, square root of 155. Boom, we're looking at wiggle equal to 12 point. And it's got a bunch of stuff. You know how the square roots go. And so we got 4, 4, 9, 8, 9, a bunch of stuff, right? And so if I'm around this to the hundredths place, that means 2 places out. It'll be 12 point and then 4, and then the 4 becomes a 5 because of that 9 after it's a 12.45. That's the hundredths place, you know, tenths and hundredths if you happen to remember. So you just put 12.45 in the answer box is what they're looking for. Anyway, that's my take on that one. We don't have to do every one of these because they're going to be pretty similar for a few of them, but I wanted to show you some other ones. Okay. Some other ones that kind of take a different face, although they end up doing the same thing. They're saying, what's the distance between the point this and the point that? Now we're in the coordinate grid, you know, and then same thing, what's the length of the segment here? And it's the same kind of thing for the last question. So let's look at those here. If they say the distance between the 2 points, there's nothing wrong with using the distance formula if you're familiar with that. The distance formula is really just taking these 2 points and doing Pythagorean theorem with them without having to draw it, you know. So that's what distance formula is if you happen to remember it. I bet you if you check on worked example 1 from Video Guy, he'll probably take you through just using the formula, you know, just, and you might remember it's something like, oh shoot, I didn't annotate, you know, whatever they say. Okay, there's something like square root, and then it'll be like X minus the other X and Y minus the other Y, and then you square them both because it's like the X distance squared and the Y distance squared. I'm not going to take you through it this way, but you can certainly do it that way. If you don't remember the distance formula, here it is. It's second X minus first X squared, second Y minus first Y squared, and then you add them up and then you square root it because we know A squared, B squared, C squared. You always end up square rooting the answer, you know? And so that's what that ends up looking like. If you want to do the distance formula, it's just distance equals all that. I don't happen to like doing it that way, but there's definitely a place for doing that. I guess, you know, if I were running into this myself and I wanted to just be lazy about it, well, I could certainly just default to the formula like that. So if you like that, it's fine. Otherwise, remember, trigonometry is also a very visual geometric type study. And so, okay, distance between the points, that's just us saying, well, here's this point is at -2, up 1. And here's this point at 0, down 5, 0, 1, 2, 3, 4, 5, down. And so the distance from this point to that point, they're just saying, well, what if I went from my house here straight to your house, right along that path? How far is it? And so you might be able to tell, or if you can't yet, you will be in a second. This is a Pythagorean theorem thing too, because we're saying, okay, instead of going down the street and around the corner to get to from my house to yours, let's just go straight there, you know? And so if we were to do that, well, here we are at this dot was at -2 up 1, and this dot was at 0 down 5. And so if we were to just figure out the sideways distance first, and then the up and down distance, then we could figure out the slant distance, which is what they're asking us for. If I were to go straight from my house to yours without going around the corner, how far is that, question mark, you know, or maybe I'll put like B for distance there, or you could put C for, you know, ABC. Some people like a C there. It's whatever. Anyway, that's the distance they're looking for. So what I would do is something like, okay, the sideways distance part, well, that has to do with x's. So here's this x is at -2, and this x is at 0. So for the sideways part, that's going from -2 over to 0. That's 2 steps, you know, 2 steps. Let's choose a different color for that. Oh yeah. From -2 over to 0 sideways, that's 2 steps. And then the up and down distance, up and down, you know, is a y value thing instead of an x value thing. So let's look at the y values. This dot is at up 1 step. It's up 1, you know, it's 1 step up. And this dot is down 5 steps. It's 5 down. So from up 1 to 5 down, we got to figure out how many steps that is. So from a +1 to a -5, we got to figure out, well, okay, how far apart are those? That happens to be 6 steps apart. You can do that by just looking at it if you like and be like, well, okay, here's 1, and then 2, 3, 4, 5, 6 steps, you know, like you would on a board game. Or else what some people do is they run the numbers and they'll just be like, well, I'll just minus them. 1 minus -5 will give you 6, you know? Or some people do the second one minus the first one. You'd be like, second one, -5 minus 1, that gives you -6. You can put -6 if you like, you know? Because in a minute we're going to be squaring them anyway, the negative will go away. So whatever. Now we got, if we look for Pythagorean theorem in there, we have triangle here, a squared, b squared, c squared, and that'll give us the distance here. So then we just run it, 2 squared plus 6 squared equals distance squared, and then dot, 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 finish it like we did the last ones, you know, this would be a 4 and a 36. Equals distance squared. I guess, you know, we'll just go ahead and run it real quick. 4 plus 36 is 40. B squared equals 40. So the distance is the square root of 40, you know. And there's different ways to simplify that, but they didn't ask us to round it off or anything. So feel free just to put square root 40 in there, you know. Be probably the best way to do it, or the easiest way anyway. And then the same thing for number 7 and number 8. Length of the line segment is really them saying, what's the distance from this dot to this dot? In the way that we were asking it before, you know, because here's the line segment. It's the path that I would travel from one dot to the next. So the distance between the two of them is the magnitude of the length here. It's the same thing as the length. And so, well, we would just handle that in the same way. If you want to, you could do this by writing out the coordinates for this, the coordinates for that, and then doing the same thing we did up there. Or you could write out the coordinates and use the distance formula like we had mentioned a minute ago. But probably the best cheater's way that I've seen on these ones, since the coordinates are kind of nice at whole numbers, you know, we don't have to worry as much about that. What you might do, since they're nice, is just be like, well, okay, here's the over part and here's the up and down part, you know. How many steps is that? 1 step, 2 step, 3 steps. So there's 3. And then how many steps is it? 1 step, 2 step, 3 steps. So there's 3 steps. And so that'll work well too. So you can do this by distance formula, doing a bunch of minusing with coordinates and stuff. Or else you can certainly just be like, well, 3 squared plus 3 squared equals the length of this segment squared. You can put L for length if you want squared, or you can put D for distance, or C for, you know, ABC squared. It's a cool cursive L, so I'm going to keep that. Length squared, and so then this is 9 and 9. Of course, that makes 18. So we're looking at the length is the square root of 18. And then, however, they don't seem to specify how they want the answer unless it's covered up by all my Zoom stuff here. So let unless, yeah, I'll move this stuff out of the way. There you go. Yeah. So it looks like they're not acting it around it or anything. So you should be okay just to leave it square root of 18. We'll talk about how to simplify those square roots. You could put it as 3 radical 2 if you like, or something fancy, but we haven't really talked about how to make this happen that way. So square root of 18 is fine. If they do want it around it, they certainly didn't mention that, Anyway, should be able to get away with that. Looking good, clear those drawings. And let me stop the recording here. Anyway, that's my take on homework number 1. I couldn't stop the recording because I still have the annotation thing going. So, okay, I think now it'll stop this time. We'll see.